Good morning, students. This is Dr. R.SRIKANTH, Assistant Professor, Department of ECE, and the course name is Switching Theory and Logic Design. Today we are going to discuss number conversion. Number conversion. So in this case, for example, you take a number, for example, that is a binary number, and you have to convert into another number of radix or base is 8. So this n is nothing but all these are digits an minus 1 up to a naught. Okay, then this is nothing but an into r to the power of n plus this a n minus 1 into r to the power of n minus 1. So like this we can write. So to convert into another, this is in binary form now. This is in binary form now. This, if you wanted to convert into octal number, that is base 8, then you divide this n with the r, that means 8. You divide with 8, you will get some, this remainder is nothing but a naught. Then whatever the quotient you will get, that you divide again with the r, you will get some remainder. Quotient you will get q2, remainder is a2, sorry a1. Again you take q2 or quotient divide with 8, you will get this remainder like this. Then you write this number as the number a2, a1, a0 is nothing but it is an octal number of this equivalent of decimal number. So for example, we will see this 53 we have to convert into a number into binary. In this case, base is 2, this base is 2, so you have to divide this number with 2. 53 divided with 2, 26. This remainder is 1, and 26 divided with 2, you will get quotient is 13, remainder is 0. Again you divide 13 with 2, quotient is 6, remainder is 1. Again 6 you divide with 2, quotient is 3, remainder is 0. Again you divide 3 with 2, the quotient is 1, remainder is also 1. Then you write again this a5, a1 1 0 1 0 1 is nothing but it's a binary number equivalent of this 53 in decimal number. So numbering system can convert a decimal fraction to a some number. For example, decimal factor. That means what? For example, 0.674. It is in decimal number. You convert into a number in, for example, binary. That means you have to multiply with 2. If it is a base 5, you multiply with 5. For example, you will take this f. F is one number. Then you have to convert this into a decimal number by this method already we discussed. Okay, then you divide. If you wanted to convert this f into another numbering system with base r, then you divide f with r, then you will get some f1 and this remainder a minus 1. Then you take f1 and divide with multiply with r, again you will get it is f2 and remainder a minus 1. Again you take f2. For example, you will see this example 0.625 is in decimal number, you convert into binary. For binary number, the base is 2, so you multiply with 2, you will get 1.25. This 1 will take as a remainder, sorry, carry, and we will take only 0.25 as a f1. Again you will multiply with 2, you will get 0.0500. Here now this 0 is carry, you take 0.55 into 2, you will get 1. This 1 is again carry. So okay, we will write this is nothing but a minus 1 This is first one is 101.0. This is nothing but binary equivalent of 0.625 in decimal. So this also we discussed already. Okay, base conversion. Already we discussed this. Expanding form of, there are two methods are there. Series substitution method. This means the expanded form of polynomial representation. Some n number is will represent whatever the number is given, will convert into decimal number by this method. Then convert procedure. For example, base A to base B. For example, base A is 10, base B is, for example, 4. Okay. Then represent the number in A in the form of equation 1.3 means what? In the, by using decimal number, then you convert. For example, you take 101001, that is in base 2, you convert into base 10. So base 10 means what? You have to take this 0 into 2 to the power of 0 plus this 1 into 2 to the power of 1, again 0 into 2 to the power of 2, again this 1 into 2 to the power of 3, this 1 into 2 to the power of 4, you will get 26. You see, for example, 268 into 268 of base 8 into base 10. Then what you have to do? The 627 of base 8 you have to convert into a number of base 10 is nothing but 7 into 8 to the power of 0 plus 2 into 8 to the power of 1 plus 6 into 8 to the power of 2 is equal to 407 of base 10. For converting, this method is for converting the integer. So for example, n1 is there and you have to convert into another number with base 8. You have to divide this one and take the quotient and remainder. Remainder will take as a 1 bit. Okay. For example, you take this 315, you convert, that is in decimal number, convert into 474 of 8. What we have to do? We have to divide this number with 8. Okay, you divide the 315 with 8. The quotient is 39 and you will get remainder is 3. Again divide with 8, you will get 7, and again divide with 8, it's not possible. So we take for 437 is, okay, this is most significant bit. The lower is most significant. The first one is the least significant bit. Okay, you convert this 315 into a hexadecimal number. In the case of hexadecimal number, the base is 16. So you divide 315 with 16. Same procedure, you will get 13p. So conversion of the fractions. In the case of fraction, what you have to do? We have to multiply. For example, you take some n and you convert that into a number with base n. You multiply this number with b and you will get this integer plus some fraction. For example, you will see this conversion of the fractions, one base number to other base number. For example, you take 0.479 of base 10 to some octal number. What you have to do? You have to multiply this with this with 8. So you multiply 0.3651, sorry, 0.479 into 8. You will get 3.87. You take this number as the MSD, most significant bit, and what is remaining? 0.832. Again you multiply this with the 8, you will get 6.652. You take this remainder, sorry, carry 6, you take 0.656 to multiply again, 0.656 into 8, you will get 5.2. You take this one like, okay. So you proceed like that. Then what is a MSD? The third 3651 like that you will get into 8. This is so here when it is conversion of the integers, this is MSD, this is LSD. In the case of fractionals, this lower is the LSD, this is most significant bit. This is a most significant bit. Okay. So base conversion. So conversion, for example, 18.6 is with the base 9. You convert into a base 11 number. So first we have to do, we have to convert this into, that is equivalent number of the decimal. So what we have to do? 8 is equal to, this number is equal to this 8 into 9 to the power of 0, 8 into 9 to the power of 0 plus 1 into 9 to the power of n plus this 0.6 no plus this 6 into 9 to the power of minus 1 is equal to 17.66. You convert now this 17.66 into this base 8. Then what we have to do? This, what is 17.66? To convert this, you divide this number with 11, and to convert this 0.66 into its fractional number equal to fractional number with base 11, you multiply. For integer you multiply, sorry, for integer you divide, for the fractional you multiply. For the 17.66, for converting the integer you divide, for converting fractional we have to multiply. Okay, same procedure. Then you will get this is equal to the 17.66 of base 10 is equal to 16.736 of base 11. List octal and hexadecimal number from 16 to 32 using A and B for the last two digits. List the number from 10 to 26 in base 12. So 16 to 32. 16, what is 6? 16 octal and hexadecimal. This is in 16 is equal to, it is, if it is in, it is called 16 in base. If it is octal 6 into a to the power of 0 plus 1 into a to the power of n. Okay, you will get 16. This is in decimal number is equal to 20 in the octal number. 32 if it is in octal number, 32 is in, now this 32 is decimal number, you convert into 8. How to convert? 32 divide with the 8, 8 4 ja 32, 0 is not taken. So this is a LSB, this is MSB. So we will take 4 0. So similarly we will do this also, base 12 also. So this is conversion of numbers from one base to numbers with other base. Thank you.